starts recording. Okay, it's recording now. All right, so you should be able to see my screen, and this is the tutorial yang kita nak discuss, accuracy and precision. So saya pinjam the first submission kat sini. Okay, so just to refresh in case terlupa, because we took like more than a week break kan. Accuracy and precision is important because when we are performing analysis, kita nak pastikan there is minimum room for error, tak nak ada ralat kesalahan, because we are dealing with assessing pharmaceutical drugs, and these drugs will be consumed by patients. So we want to make sure that drugs are safe and it works when patients consume them. So bila sakit makan, kita nak beri ubat tu berkesan lah dan selamat untuk dimakan. So one way to be sure about this, one way to assess the safety and the efficiency of these drugs, kita perlu pastikan yang analisis kita tu, kita perlu pastikan cara kita buat test tu adalah sedikit ruang untuk ada kesilapan, untuk ada ralat. So for you to understand the importance of these things, that's why you need to know about accuracy and precision. Okay. So first question dalam tutorial ni is about these dumbbells, 2 kilogram dumbbells. So this question starts with: a student picks up 2 kilogram dumbbell and placed it on a weighing balance for measurement 3 times. Maksudnya dia ukur berat, dia timbang berat dumbbell 2 kilo ni sebanyak 3 kali. Dan bacaan dia dapat adalah berlainan setiap kali. So yang pertama adalah 1.95 kilo. Kali kedua dia timbang 2.05. Dan kali ketiga dia timbang 2.10. So my question is the weighing balance accurate? Adakah penimbang tu tepat? So the answer is yes. Although dia punya bacaan tidak sebiji 2 kilo. The definition of accuracy adalah, saya letak dekat individual feedback dekat bawah ni. The definition of accuracy is the ability of an instrument or the ability of the person to measure a value close to its actual value. Okay. Kebolehan sesuatu alat ataupun kebolehan seseorang untuk mengukur sesuatu nilai terpaling dekat dengan nilai yang sebenar. So nilai yang sebenar dalam kes ni adalah 2 kilo. And setiap timbangan yang dia buat cukup, is close enough. So bacaan pertama 1.95, that's close enough to 2 kilo. 2.05 is also close enough. 2.10 is also close enough. So in lab, kalau kita buat analisis, kalau kita buat test dalam makmal, macam mana nak tahu close enough ni? What's the amount? Kalau kalau 1.90 tu close enough ke tidak? So someone might ask that question. So kalau dalam analisis, dalam makmal, setiap kali kita buat test, kita kena rujuk pharmacopoeia, which is a book that has all these procedures macam mana nak buat test. So dalam pharmacopoeia itu juga akan disenaraikan, akan ditulis dia punya specification, standard specification. Cakap kalau buat test ni, nilai dia mesti this value plus minus 5%. So plus minus 5% tu kita panggil sebagai tolerant. So kalau nilai dia 2 kilo, so kalau kita timbang berat sesuatu 2 kilo plus minus 5%. So 5% daripada 2 kilo, let me tulis this. Where can I tulis? Nak buka whiteboard. 1 minute sorry. Saya buka whiteboard ni, dia akan keluar link dekat dalam chat room. You don't have to click on it. Okay, saya kena tutup. Okay. So kalau dalam makmal, going back to my example tadi, kalau dalam makmal katakanlah kita buka, kita nak test satu ubat ni, dia kata the first thing that you should do adalah timbang dia dulu. Berapa banyak nak guna untuk test. So katakanlah kalau nak buat test ni kena timbang 200 mg and ada plus minus. Kalau tak boleh buat dulu plus minus 10%. Okay, so this is, ini kita panggil sebagai tolerance. Tolerance value adalah nilai yang kita guna untuk untuk mengurangkan, untuk how do I say this? Sebab sometimes machine, instrument tak tepat sangat. Manusia pun bila kita buat timbangan, kadang-kadang tangan bila nak timbang tu shaky, so ada benda yang ditimbang tu tertumpah. So untuk mengambil kira kesilapan manusia dan kesilapan mesin, kita bagi tolerance. Okay, we give this amount. So macam mana kita dapat this amount, kita refer to pharmacopoeia. So those people dah buat macam from a series of tests, kita dapati okay, this instrument kalau nak guna dia, kita mesti ambil kira 10% plus minus. Okay. So 10% toleransi maksudnya apa? Maksudnya kalau kita timbang, kita boleh terima value 10% less from 200 mg and 10% more from 200 mg. Okay, so kalau 10% less daripada 200 mg maksudnya 180 mg sampai 220 mg. So kalau saya timbang ubat yang saya nak test tu tengok 190 mg. So value ini is accurate, boleh diterima because it is within the tolerance value antara 180 dan 220 mg. So that is kalau dalam makmalah macam mana nak tahu value yang kita ukur tu accurate atau tidak. Kita ada tolerance value plus minus. Okay, so okay, moving on to the next question. A student picks up 2 kg dumbbell juga and placed it on a weighing balance for measurement 3 times. Okay, kawan kamu. Okay. So dia ambil 2 kilo dumbbell and placed it on a weighing balance, dia timbang sebanyak 3 kali. So the result, the reading of the weighing balance is 2.95 kilo, 2.90 kilo, and 3.01 kilo. So the question is the weighing balance accurate? So the answer here is no. Okay, because all of them are way too far off the exact value. This is the standard value, the exact value, 2 kilo. So kat sini semuanya dah close to 1 kilo. Dia punya lari bacaan dia. Okay, so that's why dia punya weighing balance ni adalah tidak accurate, tidak tepat. Question number 3. A student picks up a 2 kg dumbbell and placed it on a weighing balance for measurement 3 times. Timbang 3 kali juga. And the result was 2.95, 2.90, and 3.01. So is the weighing balance precise? Okay, so ini kita nak nilaikan dari aspek precision pula, kejituan. So the answer here is yes. weighing balance itu adalah G2. Precise, it is precise. So for you to answer this question, you have to know what does precise means. Precise, precision, kejiduan, bermaksud kebolehan sesuatu alat ataupun kebolehan seseorang untuk mengambil bacaan, untuk mengukur sesuatu bahan berulang kali dan dapat bacaan yang sama ataupun lebih kurang sama, close enough. So in this case, dalam kes soalan ni, pelajar yang tengah timbang 2 kilo dumbbell ni, ketiga-tiga bacaan dia adalah lebih kurang sama, 2.95, 2.90 dan 3.01. All three of them are close enough. So kalau dia repeat bacaan yang sama berulang kali, maksudnya weighing value itu adalah G2, precise. Okay. Next question. Anissa, a pharmaceutical analyst, performed 3 assay tests on paracetamol tablets. So assay test ni adalah satu test yang kita buat untuk menentukan kandungan sesuatu bahan. So kalau sama dia cakap, okay, buat assay test untuk PCM tablet. Maksudnya kita nak tahu setiap dos tablet PCM tu ada berapa. Okay, because kalau kita beli Panadol, ada tuliskan Panadol 500 mg, Panadol 650 mg. So those are the dose of the PCM, the active ingredient yang ada dalam tablet tu. So how do we know ada 500 mg? How do we know ada 650 mg? Kita perform assay test. Okay, so dalam cerita ni, dalam soalan ni, Anissa perform 3 assay test, dia buat 3 kali on PCM tablets ni. Dia dapati bacaan kandungan PCM adalah 98%, 100% dan 102%. Okay, so di sini kita nak assess, kita nak analyze dia punya measuring scale ni, dan dia punya instrumen yang digunakan tu adalah accurate ataupun tidak. Are her results accurate? So remember, balik the definition of accuracy adalah the ability of a person ataupun the ability of a tool, an instrument to measure something closest to its exact value, to its actual value. So the target value here is that adalah 100%. Okay, kita nak make sure the dose for each of the tablet yang kita test tu adalah 100%. Cukup lah, maksudnya 100%. Kalau dose tu 50%, maksudnya kurang sebanyak 50%. Kalau patients makan, sakit kepala ke, demam ke, tak lega-lega. So we want to make sure the dose, the API of the PCM adalah 100%. So kat sini Anissa buat test, bacaan dia dapat adalah 98, 100 and 100. The question is, adakah dia bacaan dia, results itu accurate ataupun tidak? The answer is yes. Sama macam dumbbell tadi. Walaupun bacaan dia tidak sebiji 100%, tapi two of them are close enough, 98 and 102%. Satu lagi adalah dead on, both are 100%. So therefore, dia punya result adalah accurate. Next question. Kamala, a pharmaceutical analyst also, colleague to Anissa, perform 3 assay tests on chlorpheniramine tablets to determine the amount of the API. API stands for active pharmaceutical ingredient. So still the standard value is 100%, and the results yang dia dapat adalah 98%, 199%. So my question is, are her results precise, G2 ataupun tidak? So the answer is yes, because the definition for precision is the ability of a person, the ability of a tool to measure the same substance again and again. So kat sini dia test benda yang sama, chlorpheniramine tablet, and target value dia adalah 100, and bacaan dia dapat adalah 98, 100 dan 99. Kamu tengok ketiga-tiga bacaan ni. Kamu bandingkan 98, 100 and 99. Close with each other ataupun tidak. So kalau close, precise. Okay, itu perbezaan antara precision dan juga accuracy. Kalau precision, you compare the closeness of your measurements. Okay, ketiga-tiga ukuran kamu ni, ketiga-tiga bacaan esei yang kita dapat ni, kita bandingkan antara satu sama lain. Itu precision. Dekat tak antara satu sama lain. Kalau accuracy, kita bandingkan dengan target value. So ini bacaan Anisah tadi, 98, 100 dan 102. So kalau nak tengok dia accurate ataupun tidak, kita bandingkan these readings with the target value, which is 100. So 98 is close to 100, accurate. 100 is close, is 100, so accurate. 102 is also close to 100. Okay, itu perbezaan antara accuracy dan juga precision. Moving on, Isaac, a pharmaceutical analyst, colleagues to Kamala and Ansa, he did assay test also on glycoside tablets to determine the amount of API. So the standard target value is still 100. Kita nak make sure the dose of these drugs are 100%. And the results that he gets adalah 88%, 90 and 91. The question is, precise or not, the readings, the results? The answer is yes. Although the punya accuracy is very low, okay, because the target value is 100 and all his readings are way off the mark, 88, 90 dan 91. Tetapi the question is not about accuracy. The question is whether the results are precise or not. So kita tengok, kita bandingkan ketiga-tiga bacaan ni antara satu sama lain. So 88 is close with 90, 88 is close with 91. So all of them are close enough with each other. So therefore, the results are precise. Okay, dia boleh repeat basically the same results again and again. The same situation Isaac tadi juga. Tapi soalan dia sekarang adalah whether are his results accurate. The answer is no. Okay, macam saya explain tadi, kalau nak tengok accurate ataupun tidak, we compare the results, the readings of the assay test to the target value. Okay, sini target value adalah 100 and all of them are 88, 90 and 91%. Okay. Next question. In research and chemical analysis, choose the most important criteria. So which one is more important, precision ataupun accuracy? And the answer is both are important. Okay, kamu tak boleh tepat saja. Because kalau kita buat, kamu tak boleh tepat saja tapi tak jitu, tak precise. Because bila kita buat analisis dalam makmal in the industry, we always perform, we always buat duplicate test. So kalau kita nak buat test the same batch, katakanlah datang satu ubat ni, amoxicillin tablet, ubat antibiotik, kita perlu prepare. Walaupun dia batch yang sama, kita kena prepare multiple samples. Okay, walaupun dia batch atau the carton blister yang sama, kita kena prepare 6 solutions of the same sample. So the reason why we do this adalah macam saya cakap tadi, kita nak minimize error. Kita nak make sure cara kita buat kerja tak ada ruang. There's no room for mistake bila kita buat analysis. So kalau kita buat satu saja, kita tak boleh nak compare. Kita buat ni kerja ni betul ataupun tidak. Okay, kalau kita buat 6, kita boleh compare, kita ada banyak samples, kita ada banyak data so that kita boleh analyze our ability, our precision and our accuracy and also the machine's precision and accuracy. So kita kena accurate and kita kena precise. The instrument, the machine yang kita guna pun mesti accurate and precise. Yeah? So that's why walaupun kalau kita prepare 6 sampel dan satu saja yang accurate, tapi lagi 5 tu hancur. Okay, way off the mark. Kalau target value 100 dapat the first one 100, the second one adalah 80, 90, 70. So how can we, kalau kita buat satu saja, hari ni kita buat test tu, kata minggu depan ubat yang sama juga, amoxicillin tablet juga. So kita buat satu sampel juga. Macam mana kita nak tahu sampel yang kita prepare tu adalah accurate? Maybe the first time kita buat dapat 100, tapi the second time kalau kita prepare satu sampel saja, we cannot be sure. So that's why we always buat duplicate bila kita buat analysis, chemical analysis. Next question. So the following questions will be based on this diagram. Okay, answer the following questions based on diagram number 1. Choose the dart thrower who are precise but not accurate. The correct answer adalah B. Okay, kita tengok B, kita analyze here. This person, all the darts are close with each other. Berdekatan antara satu sama lain. Tapi tak ada satu pun yang dekat dengan bullseye. This is the target here. So tak ada satu pun yang accurate. All his darts are away from the bullseye mark, tapi close with each other. So that's why dia adalah this thrower is precise but not accurate. Next one, still based on the diagram, choose the dart thrower who are accurate but not precise. So kat sini tak silap saya ada dua, but the answer here is A. So kita tengok A. They are accurate but not precise. Okay, so ada satu dart yang dia baling kat sini close to the target value dalam circle, white circle, which is close to the target value. So this dart here is accurate. Tapi the other three is way off the mark. Okay, so that's why dart thrower for board A ni dia adalah accurate but not precise. Dia ada kebolehan untuk dapat bullseye, tapi dia tak boleh repeat. Next one, choose the dart thrower who are accurate. Oh, multiple answers. So this is the one yang ada more than one answer. Choose the dart thrower who are accurate. So kenapa ada dua multiple answer kat sini? So D is the first correct answer. So let's take a look at D. So D, all of the darts fall in that center. Dekat circle merah tengah-tengah. So that's why they are accurate. Tapi macam the previous question kita ada jawab tadi, this one is also an accurate throw. This dart here is close to the target value. So therefore, A, the dart thrower A is also accurate. So, okay, so A and D is a correct answer. But D is better because he is accurate and he is also precise. Precise meaning dia boleh baling the rest, all of the darts at the center. And next one, choose the dart thrower who are not precise and not accurate. Precise tak, accurate pun tidak. So the answer here is C. Okay, so C kat sini tak ada satu pun yang kat tengah and tak ada satu pun yang close with each other. So that's why dia tak tepat dan tidak cukup. And lastly, choose the dart thrower who are precise and accurate, which is a giveaway because kita dah jawab tadi. The answer is D. Dart thrower D, dia precise dan juga accurate. Okay, so that's it untuk accuracy and precision punya tutorial. I think it's straightforward. You just need to know the difference between accuracy and precision. If you know the definition, accuracy, what is accuracy and what is precision. So if you apply the same concept macam dalam case ni pun, if you apply the same concept dalam case yang orang yang buat essay test, it is you can understand lah. Okay, so let's take 5. Tekak saya pun dah kering lah. So 2, 3, 7 kita akan sambung balik. Kita akan start discuss volumetric analysis. Somebody say something in the chat room. Yes, Durga, you raise a hand. Kenapa? Okay. Oh, okay, sila. Okay, so kalau tak ada apa-apa, uh, kita akan resume in 5 minutes. Thank you. Okay, I'm back. Alright, so sekarang kita akan continue with our lesson with chapter 2, yaitu volumetric analysis. If you look at if you downloaded the lecture notes yang ada di Google Classroom and you choose chapter 2, this is what you'll see lah, volumetric analysis, chapter 2. And before we want to continue on with the lecture, saya nak tunjuk satu video. So I want you to watch the video first, and this is the same video yang ada diletakkan dalam Google Classroom. So if the connection is somehow not clear, the visual is blurry, so you can watch it on your own device. Basically, the video yang ada dalam Google Classroom. So this is basically the setup for volumetric, a type of volumetric analysis yang kita panggil sebagai titration. Okay, so ada two solutions here yang akan bertindak balas. Satu solution yang akan datang daripada this red, this rod here, glass rod. Dan satu lagi solution dia ada dalam this conical flask dekat bawah. So kita akan add up this solution drop by drop into the solution dalam conical flask. And they will react. And kita boleh ambil bacaan how much of the solutions have reacted untuk dimasukkan dalam calculation, titration formula, titration equation. And kita boleh calculate the content, the amount of substance yang terlarut. Okay, so the purpose we perform titration, the purpose of volumetric analysis adalah we want to determine the concentration, kepekatan. So if you remember in first semester of your first year, I know you probably don't, but as a refresher, a concentration is basically the amount of solute that is dissolved in a solution, in a solvent. Okay, kepekatan. So basically contoh yang saya selalu bagi untuk explain concentration ni adalah air Milo. Kalau kamu letak satu sudu serbuk Milo dalam satu gelas air panas, kamu akan dapat larutan air Milo yang macam tawar, cerah. Kalau kita masukkan 5 sudu serbuk Milo dalam gelas air yang sama, kita akan dapat Milo kau, Milo yang pekat. So, Milo yang kau tu, dia jadi kau, dia jadi pekat kerana dia mengandungi lebih banyak serbuk Milo. So, we apply the same concept here. Serbuk air Milo yang kau tu adalah pekat kerana dia mengandungi lebih banyak serbuk Milo. So the amount of solute serbuk Milo yang terlarut dalam air tu adalah lebih banyak di dalam air. So that is the definition of concentration. That is how we define a dose of every drug. Okay, so concentration here is a substitute for dose. Nah, bagi kamu faham tentang dose, the strength of drugs. So to understand dose, the strength of drugs, kamu perlu tahu concentration, kepekatan. Okay, kepekatan bukan maksud Milo yang pekat saja. Setelah macam contohnya ubat Panadol. Okay, tadi saya cakap ubat Panadol kalau kita nak beli ada dua dos kat dalam pasaran. Ada yang 500 mg, ada yang 650 mg. So kedua-duanya adalah Panadol, tapi one of them is more concentrated. Kenapa dia more concentrated? Because dia mengandungi lebih banyak API. Dia mengandungi kandungan active ingredient yang lebih tinggi, yang 650 mg. Yang 500 mg tu, it's still Panadol, tapi dia punya concentration is lower. The dose is lower. So that's why, kalau kita nak buat test, kita nak make sure the dose is correct, kita boleh perform titration. Because from titration, kita boleh calculate the concentration. We can ascertain the amount of active ingredients of drugs by performing titration. Okay, so dalam this chapter, kita akan tengoklah how does this work. How can we actually perform, what is the step-by-step procedure to performing titration. What is required. Okay, so let me present this. After this lecture, saya nak buat satu exercise we all can do together in real time using quizzes. Okay, so please pay attention. Saya nak some participation from you guys also. Volumetric analysis, as I have said tadi, adalah sejenis quantitative analysis. This is explained dalam chapter 1. Analysis, there are two categories of analysis. One is quantitative, where we are dealing with numerical values. We are trying to determine the weight, the amount, the percentage. Okay, so kalau kita nak mengukur sesuatu, that means we are performing quantitative analysis. The second type of analysis adalah qualitative analysis. Quality, we are comparing the quality of some species of drugs, of chemical compounds yang ada dalam ubat. Contohnya, macam saya pernah bagi sekali contoh lah untuk qualitative analysis adalah limit test of certain compound. Katakanlah macam kita nak tentukan sama ada dalam ubat ni ada heavy metal ataupun tidak. So bila kita buat satu test, kita panggil sebagai limit test. Dalam pharmacopoeia kata kalau kita buat test ni, kita campur ubat ni dengan this chemical, kalau ada heavy metal akan terhasil larutan garam, akan terhasil mendakan berwarna putih. So kalau kita buat, kita ambil tablet ni, kita grind dia jadi hancur dan larutkan dia dalam solvent, kemudian campur chemical A, campur chemical B. So chemical A dan chemical B ni akan bertindak balas dengan heavy metal. Kalau ubat tu ada heavy metal, the heavy metals from the drugs, from within the mixture of the drugs will react with the chemical A and chemical B, producing a precipitate, menghasilkan mendakan. So kalau kita buat test tu, kita campur ubat kita, tablet kita tu, chemical A, chemical B, kita kacau, kita tunggu ada precipitation, ada mendakan. So we are comparing the quality, we are assessing the quality of the drug. Kita tak ukur pun apa dia. Kita tak tahu berapa banyak heavy metal dalam tu. Kita tak tahu apa lagi, berat dia berapa, percentage dia berapa. We don't know nothing about the measurement values of the thing we are assessing. We are only assessing whether it is present or not. Heavy metal ada ke tidak, by assessing the quality of the solution that we have prepared. Okay, so itu one example of qualitative analysis. Kita assess the quality of our sample. So kalau volumetric analysis ni, getting back into our chapter here, volumetric analysis adalah sejenis quantitative analysis. Kerana kita measure, kita nak ukur the amount of substance within the solution. Kita nak determine the concentration of a known reactant. Okay, so that is the definition of titration, the definition of volumetric analysis. To determine, bukan definition, the purpose, to determine the unknown concentration of a known reactant. Okay, and volumetric analysis, as I have said tadi, it is known as titration also, nama lainnya, in which a substance of known concentration and volume is used to react with another substance of unknown concentration. So that could be confusing. So let me explain that. So this is the video yang saya tunjuk tadi. So if you download this, if you download the lecture notes, you should be able to watch the video yourself. So this is the video that I showed you just now. Dia tunjuk macam mana orang tu buat titration. And how does it work? This is the explanation of how does a titration works. Okay, so what we need adalah basically two solutions. So the first one is substance of known concentration. Kita panggil ini sebagai standard solution. Kenapa dia dikenali sebagai standard solution? Because kita tahu kepekatan dia berapa. So in this case, dalam video tu, the concentration of sodium hydroxide is the name of the substance of the solution. Kepekatan dia adalah 0.1 molarity adalah unit untuk kita ukur kepekatan. Kedua, bahan yang kedua yang diperlukan adalah substance of unknown concentration. So kita nak tentukan kepekatan sulfuric acid. So kita ada sulfuric acid, kita tahu berapa volume, berapa isi padu yang kita ada, tapi kita tak tahu kepekatan dia. Okay, so that is why we are performing titration. We want to know the concentration of sulfuric acid. So how does it work? When we perform titration, kita akan masukkan drop by drop the standard solution, which is the sodium hydroxide tadi. Okay, so this is the standard solution. Kita akan masukkan drop by drop of sodium hydroxide into sulfuric acid. So mereka akan bertindak balas sedikit demi sedikit. So what is the point? The point is kita nak bagi mereka bertindak balas sampai the end of the reaction. Okay, so that could be confusing. So saya suka bagi contoh kat sini. Kamu tahu tak bath bomb? Bath bomb is a type of soap yang kita boleh orang selalu guna for bathing, masukkan letak dalam tub and we could take a bath with it. So how it works adalah it is a combination of sodium bicarbonate dan juga citric acid, and orang akan add in lah all the fragrance, some coloring pewarna sebelum masuk dalam tub. Dia akan jadi wangi, dia akan the color of the water in the tub akan jadi berwarna lah depending on the color yang kita letak. So bila kita masuk, kalau kita orang tengok bath bomb, it's basically in any shape. Bila kita masukkan this bath bomb dalam air, dia akan jadi menggelegar. Okay, dia akan jadi macam fizz, macam kalau kita campur Mentos dalam air Coke, tapi dia tak akan jadi explosion, dia akan just fizz. Dia akan jadi berbuih-buih, dan lama-kelamaan buih itu akan habis and it ended. So my point here is kenapa dia ended, kenapa dia habis. Okay, so basically a bath bomb works because sodium bicarbonate dia akan bertindak balas dengan citric acid bila dilarutkan dalam air. So bila kedua-dua bahan ini, sodium bicarbonate dan citric acid, bertindak balas dengan satu sama lain di dalam air, dia akan menghasilkan karbon dioksida dan juga garam. So buih-buih, the fizziness that comes out from the reaction itu adalah carbon dioxide. And mendakan yang terhasil at the bottom of the bathtub adalah garam. Hasil daripada tindak balas sodium bicarbonate and juga citric acid. So my point here is kenapa it ended. Bila kita masukkan bath bomb kat dalam bathtub tu, dia akan fizz, dia akan jadi berbuih, tetapi lama-kelamaan dia akan habis. Kenapa dia habis? So the answer is because everything has reacted with each other. Sodium bicarbonate yang ada dalam bath bomb tu dan juga citric acid yang ada dalam bath bomb tu telah bertindak balas dengan satu sama lain. Setiap zarah atom yang ada dalam bath bomb tu of citric acid dan sodium bicarbonate telah bertindak balas dengan satu sama lain sampai habis. There's no more sodium bicarbonate, there's no more citric acid. That's why the reaction stop. That's why tak ada bubble lagi dah. That's why tak ada buih lagi dah. Carbon dioxide sudah tidak boleh dihasilkan lagi. Sebab sodium bicarbonate dah habis digunakan, citric acid pun dah habis digunakan. Okay, so this is basically the same thing. This is a chemical reaction. So bila kita buat titration, kita nak sodium hydroxide ni bertindak balas dengan sulfuric acid sampai habis. Okay, so why do we want to know that? Because kita nak ukur kalau dah sodium hydroxide ni dah bertindak balas dengan sulfuric acid sampai habis, kita boleh ukur the amount of sulfuric acid yang bertindak balas. Because at some point reaction tu akan habis because semua sulfuric acid sudah digunakan untuk bertindak balas dengan semua sodium hydroxide. That's why kita kena tahu uh, uh, concentration sodium hydroxide ni, because this value will be used dalam titration equation. Okay, so bila kita titrate, the color will change. So this color change dibantu dengan indicator solution. Okay, tadi dalam video yang saya tunjuk tadi, bila dia titrate, at one point the color of the solution tukar jadi warna light pink. So that means the sulfuric acid sudah habis bertindak balas dengan sodium hydroxide. So stop titration, ambil bacaan. So ini bacaan yang dia dapat dalam video tu. So the amount of sodium hydroxide solution digunakan adalah sebanyak 9.57. Volume of sulfuric acid digunakan yang dalam conical flask dekat bawah tu adalah 10 ml. So we record these values and then kita masukkan dalam titration equation, which is M1 V1 equals to M2 V2. So you must remember here, kita sini nak tentukan kepekatan sulfuric acid. Okay, so M is the unit for concentration, molarity. V stands for volume. So to perform the calculation, we just fill in the blanks. M1 adalah the concentration for sodium hydroxide, darab dengan the volume of sodium hydroxide yang digunakan. Okay, so 9.5. So multiply these two, samakan dengan M2 darab dengan 10 ml, which is the volume of sulfuric acid. So M1 V1 adalah values untuk sodium hydroxide, M2 V2 adalah values, nilai bacaan untuk sulfuric acid. So then we solve for M2 lah, because M2 is the molarity of sulfuric acid, the molarity for sulfuric acid. So after we do the calculation here is, kita dapati the concentration for sulfuric acid adalah 0.9589. Okay, so that is how we use the titration equation by using the values yang kita dapat from titration. Okay, so that is how we can determine the concentration, the dose of a substance of a drug using titration. So what is the standard solution, which is I have explained about a bit before. A standard solution is a substance that we know the concentration. Kalau kita tahu kepekatan dia, kita tahu kandungan dia, maka dia adalah a standard solution. That is the definition of a standard solution. Okay, so kat sini kita ada dua bahagian untuk standard. So kita ada primary standard and a standard solution. So a primary standard, which is just a term yang kita guna dalam industri untuk kita kenal pasti bahan yang mengandungi bahan yang stabil. Okay, it is a stable chemical compound. Kenapa kita nak stabil? So primary standard ni adalah kalau dalam analisis kita gunakan dia sebagai rujukan. So kalau kita nak gunakan dia sebagai rujukan, dia mestilah tak mudah dipengaruhi oleh persekitaran. Kerana apa? Kerana dia mesti kualiti dia mesti yang terbaik. Kalau dia mudah bertindak balas dengan persekitaran, mudah macam kalau kena cahaya, dia boleh kualiti dia menurun. Kalau dia terdedah pada udara set saja dalam 1 minit, dia kualiti dia dah menurun. So that is not good. That is not good quality if you want to be a standard. Sama lah macam makanan. Kalau makanan kamu masak mie goreng, kamu letak mie goreng basah, kamu letak dekat atas meja, lambat nak makan sebab busy bekerja ke apa, within 30 minutes sudah basi dah. That's not a good thing kan. So anything that is easily reacting with the surroundings, with the environment, is not a good criteria, not a good quality for it to have, because it cannot be a standard, okay, a reference standard. So that's the first quality for any standard to have. So stable chemical compound. Dia mesti juga high in purity, mempunyai ketulinan yang tinggi. and also kalau dia mempunyai kedua-dua kualiti ini, ia boleh digunakan untuk standard solution. I'll explain about this later. So to explain about this, kejut ada guru. Standard solution pula in the industry kita panggil dia sebagai apa nama, secondary standard. Okay, so basically kat dalam kilang kita perlukan, bila nak buat analisis kita perlu ada standard solution. So untuk kita dapatkan standard solution ni, kita perlu beli from pharmacopoeia, US pharmacopoeia ke, British pharmacopoeia ke, and these reference standards are very expensive. Dalam satu vial yang kecil sebesar ibu jari saya ni, it contains about 100 to 200 milligram, sikit saja, but it can cost up to 10,000 ringgit. So it is very expensive. So kalau kita buat penama ubat dekat kilang, and every day ada like thousands, and every month it amounted up to 10 million tablets. Okay, so banyak test yang perlu dibuat. So banyaklah standard solution yang perlu digunakan. So we cannot afford to keep buying this reference standard banyak-banyak. So one way to solve this adalah kita dibenarkan untuk buat standardized reference standard. Bermaksud kalau contohnya kita nak test ubat Panadol, okay, so kalau nak test ubat Panadol kita perlu beli reference standard from USP, which is US Pharmacopoeia. Katakanlah harga dia RM10,000 for 100 mg, very expensive. So kalau seminggu pakai 100 mg. So kalau 2 minggu dah 200, that's 20k. 3 minggu dah 30, and sebulan dah 40k. So to jimat, untuk mengurangkan perbelanjaan, cost manufacturing, kita boleh buat our own standard solution. So how do we do that? Kita beli reference standard 100 mg, and then kita order a raw material. Katakanlah kita dapat supplier from China, they can supply 10 kilograms of PCM, of paracetamol. Tapi it is cheap. Kenapa dia cheap? Because we don't know the concentration, we don't know the purity. Kita tak tahu ketulinan dia berapa. So kalau kita beli reference standard from US Pharmacopoeia, dia ada certificate of analysis. USP dah buat analysis, dah determine this, the content of PCM within this vial adalah 100%. So bila kita beli, kita boleh gunakan dia terus. So kalau kita beli from that Chinese supplier tadi tu, we can buy cheap for 10 kg, tapi we don't know the concentration. But we can perform titration analysis untuk dapatkan dia punya kepekatan. We can do that ourselves. So kita beli 10 kg, so bila sampai pada lab, kita buat titration macam yang kita tengok dalam video tadi. Kita buat calculation and kita dapati the concentration, the purity adalah 98%. So which is close enough to the target value. So now we have 10 kilograms of standard solution. Okay, itu perbezaan antara primary standard solution dan juga your secondary standard solution. Okay, so that's the definition of the standard solution here is adalah a chemical reagent ataupun solution with accurately known concentration. Kita dah determine, kita compare the raw material yang kita beli from China tadi dengan the reference standard yang kita beli from USP, US Pharmacopoeia. Okay, that is the difference between primary and standard solution. Okay, and these are the qualities, the characteristics of any primary standards. Not hygroscopic, meaning tidak mudah bertindak balas dengan kelembapan, tidak mudah menyerap kelembapan. Okay, not hygroscopic. High purity, mengandungi ketulinan yang tinggi. High stability, sangat stabil, and high molar mass. Bila molar mass tu besar, dia tidak mudah bertindak balas, tidak mudah dipengaruhi oleh bahan-bahan yang lain. So ada 4 kualiti untuk sesuatu bahan itu menjadi primary standard. These are some examples of some chemicals and its uses as reference standard. So not all chemical can be reference standard untuk macam kalau kita nak buat test of certain chemical compound, kita perlu guna specific substance. So contohnya kalau kita nak standardize sodium hydroxide solution, kita kena guna potassium hydrogen sulfate. Kalau kita nak standardize, kalau kita nak test acetyl superchloric acid, kita boleh guna potassium hydrogen sulfate. Kita tak boleh guna potassium iodide untuk test untuk standardized hydrogen solution. Itu maksud saya. Okay, dia ada sebab dia lah. Tapi these are the examples of the usual pair. Primary standard potassium hydrogen phthalate digunakan untuk ini. Zinc metal digunakan untuk ini. Okay, so these examples the ones yang selalu digunakan dibuat dalam makmal. Okay, and from here on forward, dia adalah saya sediakan, saya letak slide by slide, step by step macam mana nak prepare, how to perform titration. So these are the apparatus required and reagents required, and from here on is the step by step guide, how do we perform titration. So I would prefer you would watch the videos yang ada dalam classroom, Google Classroom. Because kalau video you can visualize, kamu boleh nampak. Kalau baca ni you don't know because kamu bukan kerap masuk lab, so maybe kamu tak tahu pipette ni apa. Use the pipette, prepare desired volume. Dropper ni apa, indicator solution ni apa. So kalau kamu nak baca ni, I would prefer for you to watch the video first and then baru baca step by step. Okay, because kalau kamu baca, lepas kamu tengok the video, kamu boleh gambarkan dalam kepala kamu. Kalau kamu baca saja without the video, apa pun tak boleh. Okay. So as you have seen dalam video tadi tu, and also as I mentioned tadi, bila kita buat titration tu sampailah warna solution dalam conical flask tu berubah jadi light pink. So why does this happen? Kenapa? Why did the color change? So the color change, as I have said tadi, the color change because the standard solution has reacted completely with our sample solution. Semua dua-dua bahan dah bertindak balas sampai habis. So kenapa color change? It is because dalam that video dia guna an indicator solution to indicate that the reaction is complete. So kenapa dia jadi warna pink? So kenapa dia jadi warna pink is because dia guna indicator solution yang bernama phenolphthalein solution. Okay, so phenolphthalein solution ni bila dalam acidic solution, kita campurkan 2-3 drop dalam acidic solution, warna dia tak akan berubah, dia jadi color, dia akan maintain still colorless. Tapi bila kita titrate, lama kelamaan that acidic solution dia akan digunakan sepenuhnya untuk bertindak balas. So dia bukan lagi acidic solution. Dia dah jadi neutral, and kalau kita tambah lagi sodium hydroxide dalam that acid solution, dia akan jadi a basic solution. So the thing with phenolphthalein is, kalau dia dilarutkan dalam a basic solution, dia akan jadi warna pink. So kalau kita titrate, kita keep on titrate, masukkan drop by drop of sodium hydroxide into the acid solution, lama kelamaan dia akan jadi basic. So that's why warna dia berubah jadi warna pink, because dia bukan lagi acidic. Dia bukan lagi larutan asid. Dia sekarang dah jadi larutan base. Okay? So this point at the color change ni kita panggil sebagai end point. Okay, so this is the point at which the reaction is complete. Dah bertindak balas sampai habis dah. Okay, remember my example bath bomb tadi tu. Kenapa bila kita masuk ke dalam air, dia akan berbuih, and then lama kelamaan buih itu habis and it stops reacting. Okay, because everything has reacted to completion. Wait a minute, ada orang baru join. Miss Santini. Durga, you ask a question. So sometimes saya tak dengar. Ada orang tulis something dia. Kalau saya tak jawab, please just turn on your mic and ask. So Durga, you asked how to know the standard solution. I'm not sure I understand your question. Kamu nak elaborate? A standard solution is a solution that we know the concentration. So kalau kita tahu, we know the concentration. Juga pernah tanya lagi kat sini, how to know the concentration of a standard solution. So we perform titration. We perform titration, get the values. Macam dalam slide yang saya share tadi. We do the titration equation here. Okay, bila kita buat titration tu, kita nak tahu berapa banyak amount of standard solution yang diperlukan. So bila dah color change, kita record, we stop titrating and we record how much standard solution is used sampailah warna berubah. So dalam that video that I have showed you, bila dia titrate and warna berubah, dia stop and bacaan pada burette adalah 9.57. Maksudnya 9.57 ml of standard solution is required for the reaction to be completed. 9.57 ml of sodium hydroxide diperlukan untuk bertindak balas dengan 10 ml of sulfuric acid. So we can use this value here untuk dimasukkan dalam titration equation 9.57 here. So this is how we find the concentration of a solution. Does that answer your question? Kalau saya tak jawab, you can clarify. Tanya lagi apa yang kamu tak faham. Clear or not? Kalau tak clear, maybe the exercise later will help ataupun tutorial. Okay, so kalau tak ada soalan lagi, saya nak sambung. Okay, so expression of concentration. Okay, so this is the last topic. After this, kita akan buat, we're going to take 5 and then kita akan buat the exercise that I said earlier. So expression of concentration, bila kita cakap tentang standard solution, bila kita buat analysis, concentration is very important. So dalam this syllabus, saya nak kamu faham, there are many ways we can express, kita boleh ukur concentration. Dalam syllabus ni, we are going to venture into three ways. The first one is molarity. Okay, nama dia adalah molarity, unit dia adalah capital M. So definition of molarity adalah the number of moles present in 1 liter solvent. So this is why kamu belajar tentang mole, kiraan mole in your first semester dulu. Okay, so the definition of molarity adalah the amount, the number of moles that is dissolved in 1 liter solvent. Itu definition molarity. Yang kedua, unit expression of concentration yang kedua adalah molality. Unit dia adalah lower case, M kecil. So the definition of molality adalah the number of moles present in 1 kilogram solvent. And the last one adalah normality. The unit is capital M, and the definition is the mass in gram of solute that is dissolved in 1 liter solution. So ada sebab kenapa ada banyak expression. Ada 3 kat sini. It is because some substances yang ada dalam makmal, some substances of drugs, the chemical substance of drugs, maybe dia tidak mudah, maybe it is bila kita nak buat kerja dalam measure expression, the mass in gram. Ada sana yang lebih baik, lebih mudah dibuat, lebih efisien untuk buat kalau kita measure the volume. So kat sini that's why bacaan in 1 liter. Kat sini kena timbang 1 kilogram of salt. So that's why ada banyak expression of concentration. But basically it express the amount of solute dissolved in solvent yang ada dalam solution. Okay, so that is basically chapter 2. Okay, kamu kena, the goal of this chapter adalah untuk perkenalkan pada kamu about titration, the purpose of titration, what can we do with titration, how do we perform titration, and standard solution. Okay, what is standard solution, how to identify a standard solution. Okay, so do you have any questions? Let me check. Durga asks, M1 tu dapat macam mana? So let me go back. M1, oh, M1 is the concentration of the sodium hydroxide. We know already. Okay, so sodium hydroxide is the standard solution. We know already. So kalau dalam makmal, kita boleh tentukan sodium hydroxide punya concentration ni beforehand. Okay, so this is how do we know the concentration of sodium hydroxide. So kalau there are many ways we can know the concentration of the standard solution. Either we buy from a pharmacopoeia, USP ke, PP ke, JP ke, EP ke, and they already ascertain, they already find out the concentration of the standard for you. Okay, so that's how we know the concentration of the standard. Ataupun cara yang kedua, macam saya cerita tadi, we buy a raw material and we determine the concentration. Kita cari sendiri, kita buat titration, kita find out the concentration ourselves by performing titration also. Okay, so the value of M1, either we already know, we buy from the pharmacopoeias, ataupun we can find ourselves. Yes, they give. So this is, I'll show you a picture. USP reference. There's a reason why this reference standard yang saya cerita tadi is very expensive, because it has been analyzed. So these are some of the this is what the reference standard looks like. So dekat dalam these labels, dia nampak tak? It's at the back. So dia akan tulis pada label-label ni, what's the concentration, what is the percentage of the concentration. Kat sini 100 mg, tak nampak. So kalau kita beli, if we purchase this reference standard, they will come to us with a certificate of analysis, sijil yang mengesahkan ianya sudah dianalisis. Okay, so maksudnya USP dah sijil tu membuktikan USP which is US Pharmacopoeia sudah perform test on this standard substances. Dia dah ketahui berapakah kandungan dia, what is the percentage, how many milligrams, dia punya appearance ni betul ke color putih saja, ke sepatutnya ada warna yellow, something like that. Okay, so they will always give, if you purchase from pharmacopoeia, tak kira lah USP ke, US Pharmacopoeia ke, British Pharmacopoeia ke, Japanese ke, European ke, they will always give these details to you when you purchase from them. Kalau kamu feel like you don't have the funds, don't have the money, because it is very expensive, these things, and just I mentioned tadi, it can go up to 10,000 ringgit. So you can buy raw materials and you can make your own standard substance. You can determine your own standard substance. Okay, so thank you. So let's take 5. We will do not this one, an exercise together. I'll give you the link before we stop for rest, so that you can join. So only 11 questions. Ya Allah, lembang. Sorry lah guys. My laptop is... Okay, instructor pace. So I prefer this instructor pace because saya nak tengok after every question semua orang jawab, I can explain. So kalau ada orang jawab salah, kamu boleh tahu, you can learn. So 11 questions. So don't worry, this will not be in your assessment. Maksud saya, this will not be your count as a part of your grade lah. Okay, this is not continuous assessment. This is just for me to assess whether you understand or not apa yang saya cerita panjang-panjang tadi. Lambat ni nak dapat link. Okay, let me get the link. Kamu join dulu and then let me take a break. Taruh saya kering lagi sekali. Okay, so the link is in the chat room. So just click on the link, okay? So after 5 minutes, saya akan datang balik. Okay guys, I'm back. So this will be the last session of our class. The quiz is, where is it? So thank you for joining. I'll start now. So this will be a quiz about volumetric analysis. So question number 1, volumetric analysis is what type of analysis? This is the first thing that we come across at the beginning of this lecture. So there's a time limit. Kalau kamu tak perasan. Okay, so basically volumetric analysis is a quantitative analysis. Ini yang kita tengok. Okay, so ada lagi yang salah. Okay, remember volumetric analysis kita nak measure concentration, kita nak cari kepekatan, and kepekatan is something that ada value yang perlu diukur. Okay, because kita nak tengok berapa banyak amount of solute yang larut dalam a certain amount of solvent. So when we are dealing with measuring of anything, that is a quantitative analysis. Okay, quantity, remember the punya root word is quantity. Kita nak determine the quantity. Qualitative, kita just assess the quality. Macam contoh yang saya bagi tadi, kalau kita nak find out whether ubat yang kita buat tu ada kandungan heavy metals ataupun tidak, we perform a limit test, and dalam procedure kata kalau ada limit test, after kita campur chemical A and chemical B, larutan tu jadi keruh. Okay, sebab mendakan terhasil. Mendakan ini terhasil sebab the heavy metals will react with the chemical A and chemical B. So kalau heavy metal ada, dia akan bertindak balas dengan chemical A and B. Maka mendakan terhasil. Kalau heavy metal tak ada, maka tak akan ada tindak balas lah dengan chemical A dan chemical B. So mendakan tidak akan terhasil. Kita tak ukur anything. We are not measuring anything in qualitative analysis. Okay, we are assessing the quality. Next question. What do we determine using volumetric analysis? Ada 4. So bagi yang tak boleh join, ada 4 pilihan. These are the options: amount, concentration, density, and solid. Okay, thank you. So in volumetric analysis, we are trying to determine the concentration. Okay, that is the the objective of volumetric analysis. From the concentration, we can find the amount. From the amount, we can find density. Okay, so the first goal, our main objective adalah concentration. Menggunakan matematik, kita boleh cari benda-benda lain tu, amount, density. Next question. Ada 11 slides saja, 11 questions. Choose the correct definition of a primary standard solution ataupun reference standard solution. Apakah definisi yang paling tepat untuk primary? Remember tadi saya cerita ada 2 jenis standard, a primary and a secondary standard solution, a reference and a working standard solution. So apakah perbezaan? Apakah definition of a primary standard? Okay, so primary standard tu adalah sama dengan reference standard solution. Let me buka full screen. Still cannot see. Okay, 1 second. Okay, time's up. So the first option is the right answer. Substances that are stable chemical compounds and available in high purity. Itu kriteria utama for any substances to be a primary reference standard ataupun a reference standard solution. Dia mestilah stabil dan juga dia mestilah mempunyai ketulinan yang tinggi. Next question. Kalau kamu ada soalan, kamu macam tak faham kenapa jawapan tu kenapa jawapan tu is the right answer, just turn on your mic and tanya. Okay, next one. Working standard or secondary standard solution are substances with concentration or purity that has been determined analytically using what? Macam mana kita cari concentration of a secondary standard solution ataupun working standard solution? Time's up. Okay, so kita boleh gunakan kedua-dua ini kerana kedua-duanya adalah benda yang sama. Okay, this is tadi saya ada cerita macam mana kita boleh buat standard solution kita sendiri, yang mana kita beli a raw material, we purchase a raw material from a supplier that is not from any of the pharmacopoeias. Dia bukan daripada US pharmacopoeia, bukan daripada British, bukan from the European, bukan from the Japanese. So they sell the active ingredient. Katakanlah kita nak buat test Panadol, kita perlukan a reference standard. We need a PCM solution, yang mana dia hanya mengandungi PCM saja. Because our tablet tu adalah a mixture. We have mixed the API, the active ingredient, with all the other excipients, all other ingredients. So the punya ketulinan is very low. So we need to compare it to something that is of high purity, ketulinan yang tinggi. Kalau kita nak test dia punya API, which is PCM, Panadol, dia punya API adalah PCM, paracetamol. So kita kena comparekan the tablets to a PCM substances, PCM substance, PCM solution, PCM standard solution. Okay, so kalau kita beli from the raw material, the PCM, the paracetamol chemical compound from a supplier, tadi saya bagi contoh from a Chinese supplier, we purchase the PCM from them, and then bila sampai pada kita akan determine the concentration. We perform an assay test, kita dapati okay, the concentration of this PCM that we purchase from China adalah 98%. So that is the purity, that is the concentration of the raw material yang kita beli. So bila kita dah tahu the concentration, dia boleh jadi a standard solution. Okay, so itu yang dia kata kat sini, a working standard ataupun secondary standard solutions are substances with concentration or purity that has been determined using primary dan reference standard. Okay, raw material yang kita beli from China tadi tu, kita kena test dia, kita kena determine the concentration by comparing it to a reference standard. Okay, the ones yang kita beli from pharmacopoeia. Okay, next one, halfway there. The following are the characteristics of a primary standard accept. Okay, macam mana kita nak kenal pasti a primary standard, a reference standard. Dia ada banyak tadi, dalam lecture note saya ada 4. So kat sini ada 4 pilihan. So dia tanya kat sini accept, which is not the characteristics of a primary standard. Time is up. Most of you have answered. So accept high chirality, good. Okay, so ramai orang jawab betul. So not hygroscopic is a quality of a reference standard. Okay, not hygroscopic means dia tidak mudah. It is not easily reacting with moisture. Okay, kita tak nak kita punya standard substance bertindak balas dengan kelembapan. Kalau dia mudah bertindak balas, mudah menyerap kelembapan, it will go bad easily. Okay, high purity is also a quality. Okay, kita nak kita punya bahan tu mempunyai ketulinan yang tinggi. High chirality is not a thing, it's just something I made up. Okay, it's not totally made up. Chirality is a thing, tapi high, you cannot measure chirality. Okay, so high chirality is not a thing. High stability is also a characteristic of a primary standard. Okay, next one. Choose the correct definition for molarity. Okay, remember at the end of the lecture notes, there are 3 expression of concentration. Apakah the definition? Apakah definisi untuk molarity? Okay, time is up. So the right answer is the first one. The number of moles of solute in 1 liter of solution. Okay, so this is no other way around this lah. Kamu tak boleh nak goreng, kamu kena hafal perbezaan antara molarity, molality dan juga normal. Next question, choose the correct definition for molality. So if you answered the first one tadi betul, so this one should be like you eliminated one of the options. Okay, same options macam tadi. So you basically have a 50 chance of getting this one right. Ada lagi orang jawab. Ini molarity. Okay, the first option is for molarity. So 2 orang ni, make sure, pay attention. So the right answer is the second one. Okay, the moles, number of particles, number of moles of solute per kilogram of solute. Molarity, molality, and normality are expressions of concentration. So this is true or false. Betul ataupun tidak. Which is a giveaway lah because we've discussed 2 concentration questions before this. Ada lagi orang jawab false. Macam mana? 4 orang. Kenapa setiap ada orang jawab false? The answer is true. Okay, so they are an expressions of concentration. Kita boleh express kepekatan menggunakan ketiga-tiga unit ini. Molarity boleh, molality pun boleh, normality pun boleh. Sama lah macam kamu nak express kalau kamu nak tahu macam mana nak bagi contoh. If you want to express joy, okay, so you want to express your feelings, joy. So you can either laugh, smile, you can do like, ada pelbagai cara for you to express the feeling of joy. So the same thing applies untuk concentration. Okay, benda yang sama, kamu nak express your feeling of joy, tapi you're doing it differently. Ada sebabnya kenapa you are doing it differently. So the same thing basically, tapi it is more technical bila kita cakap tentang concentration. Ada sebab kenapa ada various ways to express. Because technically in labs we are dealing with chemical, we are dealing with different instruments. Okay, so kalau tak cukup we don't have certain instruments, we are dealing with chemicals that is not safe to be measured using weighing balance, we have other options to express concentration. Okay, so molarity, molarity, and normality are expressions of concentration. Okay, third last question. Concentration is a way for us to express the amount of substance dissolved in solvent. True or false? Betul ataupun tidak? Ada lagi orang jawab false. So this is why I repeat. Basically secara natijahnya benda-benda soalan for the past 5 question ni benda yang sama we are dealing. The definition of concentration. So sampai sekarang ada macam almost half jawab salah. So the answer is true. Okay, concentration, kepekatan, molarity, molality, normality is a way for us to express the amount of substance dissolved in a solvent. So kalau molarity kita express dari segi berapa banyak bilangan mol yang larut dalam 1 liter air. Kalau saya nak prepare macam air lemon, okay, saya perlu perah lemon untuk dilarutkan dalam air panas. 1 liter air panas katanya. So kalau saya nak tahu kepekatan air lemon tu, saya boleh express dia by finding out. Saya boleh kira bilangan lemon yang larut dalam 1 liter air tu berapa. Itu satu cara. Cara kedua saya boleh timbang. Okay, saya perah dulu air lemon, saya timbang dia berapa gram. So jus lemon tu saya larutkan dalam 1 liter. Itu adalah molality. Cara ketiga adalah apa tadi? Normality. Mole juga, the number of moles. So number of moles in 1 kilogram. So saya timbang 1 kilogram air, saya kira bilangan mole lemon yang larut dalam 1 kilogram. Saya nak tahu berapa banyak lemon yang larut dalam 1 liter air. Tapi ada pelbagai cara saya boleh buat sedemikian. Okay? So itu maksud concentration. Kita nak tahu berapa banyak bahan yang terlarut dalam solvent, dalam pelarut. Okay, second last question. 5 molarity solution can be diluted to 10 molar solution. True or false? Make sure jangan pergi adik buang anything. Tak pegang anything. Okay, time is up. Ramainya orang jawab true. This is not true. Okay? So you cannot dilute a less concentrated solution to a more concentrated. Diluted means kamu cairkan. Okay, kalau 5 molar is a more diluted solution. What's the word? 5 molar tu menunjukkan kandungan solute yang lebih rendah berbanding dengan 10 molar. Okay, 10 molar maksudnya dia ada lebih banyak solute, dia ada lebih banyak bahan yang terlarut dalam bahan pelarut. Kalau saya ada saya suka bagi contoh air Milo. Kalau kamu pergi kedai mama, kamu order air Milo, katakanlah kamu nak Milo kau, maksudnya kamu nak Milo yang pekat. Okay, so sorry, my bad. That is for different situation. Kamu nak kurang manis, okay, kamu pergi kedai mama, kamu order teh tarik kurang manis. Tapi bila sampai pada kamu, when the drink comes to you, kamu minum, you take a sip and it's very sweet. Tak rasa macam kurang manis pun. So you call up the person, cakap tolong bagi kurang manis. So what can that person do adalah dia boleh kurangkan, dia boleh tuang half of the teh tarik tadi tu in another glass and then dia top up water. So what he did is dia dah cairkan daripada air yang manis tadi tu, dia kurangkan half. So the amount of sugar yang ada dalam gelas in the beginning tu sudah dikurangkan by half.
So dia cairkan, dia kurangkan kepekatan gula yang ada dalam teh tarik tu. Itu maksud dilution. You are diluting, kamu cairkan kepekatan. So dalam soalan ni saya tanya, boleh tak concentration solution yang mana kepekatan dia adalah 5 molar, boleh tak ia dicairkan kepada 10 molar? So that is not possible. Kamu tak boleh cairkan sesuatu untuk dia mempunyai lebih banyak bahan yang larut dalam tu. Okay, that is what we call kamu tambah kepekatan. Okay, the only way for the molarity value to go up adalah dengan menambah kepekatan. So kalau saya dalam contoh yang sama tadi tu, kalau saya saya beritahu ni order teh tarik kurang manis, and saya minum rasa manis, and saya panggil kata tolong kurangkan manis, dia pergi back to the kitchen, dia tambah lagi susu pekat. So dia tambah kepekatan. So that is not a dilution. Dia tidak buat dilution, dia tambah kepekatan. Okay, so remember dilution and concentrate, how to perform a dilution, meaning kamu kurangkan kepekatan. So daripada 5 kepada 10, that is not pengurangan. Alright, so last question. M1 V1 equals to M2 V2 is a titration equation. What does M stands for? Tengok adik saya. Yes. Okay, last question. Time is up. The right answer adalah concentration. Ramai jawab morality. Okay, morality is not the measurement and expression of concentration. The one you're thinking of adalah molarity. Okay, so and morality is an expression of concentration. So this is basically a trick question lah. So if you pay attention, so kalau kamu faham, concentration tu is the amount of solute dissolved in solvent, then you would know that molarity is a part of concentration. Okay, morality adalah sebahagian concentration. Okay, so that's it for today's class. Yes. So that's it for today's class. Thank you. You didn't do very well. Saya tak pasti sebab apa. Kita boleh discuss lagi because after this akan ada tutorial, and as per usual macam in the beginning tadi, lepas kamu buat tutorial tu kita akan discuss dalam kelas. Okay, so later saya akan I'll put up the tutorial for this chapter dalam Google Classroom. And we will discuss that in our next class. Okay, so congratulations for the top 3. So do you have any questions berkenaan our lesson today? Okay, so kalau tak ada apa-apa, thank you. Ada semua, hopefully semua dah sign in attendance, tak ada yang tertinggal. Kalau ada yang belum sign in, please share link kat sini. Please sign in to today's attendance. Kalau tak ada apa-apa dah, thank you. See you in next class. Make sure buat tutorial lah. Thank you all.